Welcome back, class. Today we are looking at transformation of functions, in particular horizontal translations, and this is part 2 of our lesson. Just to review, we have f of x equals a times x minus h plus k. A is our scale factor. H will move the graph either right or left. Think of it as a hypocrite because it does the opposite of what you see. And k will move the graph either up or down. And with k, you keep the value. In our last video, we used a horizontal translation to graph a line, a parabola, a square root function, a cubic function, an absolute value function, and a cube root function. With these in mind, let's look at some questions that are a little more challenging. Problem number 7. Given the parent function f of x equals x squared below, sketch the graph of f of x plus 4 minus 3. Let's analyze what we have. We have the plus 4, which is inside our parentheses. That's our h value. And remember, h is a hypocrite, so let's do the opposite of the plus 4. Instead of going 4 units to the right, the graph is going to move 4 units to the left. And our k value is -3 since it's outside. And with k, we actually keep it. So that -3 means that we're going to move the graph 3 units down. Or in other words, translate the graph 3 units down. Now let's pick 3 points from our parabola and move those 3 points 4 units to the left and 3 units down. The 3 points I want to use are 0, 0, -2, 4, and 2, 4. And once again, you can pick any 3 points you want. Let's move -2, 4 first. So let's move it 4 units to the left, 1, 2, 3, 4, and 3 units down, 1, 2, 3. Now let's move 0, 0, 4 units to the left, 1, 2, 3, 4, and 3 units down, 1, 2, 3. And finally, let's move 2, 4, 4 units to the left, 1, 2, 3, 4, and 3 units down, 1, 2, 3. Draw the graph. The graph moved 4 units to the left and 3 units down. Now let's move on to problem 8. In the graph below, f of x is the parent function graphed in bold, and the graph of g of x represents a transformation of the graph of f of x. So our parent function is the one in bold, and the transformation would be this. Give an equation for f of x. Okay, well, because the graph looks like a V, I know that this is going to be an absolute value function. F of x is the graph that's in bold. That's our parent function. So I know f of x equals the absolute value of x. Now I need to give an equation for g of x. G of x is going to be what we highlighted. If we look at the difference between f of x and g of x, notice how the difference between the two functions is that g of x moved 3 units to the right. And because it moved 3 units to the right, the equation, the function, is going to be g of x is equal to the absolute value of x minus 3. So it's inside of the absolute value bars because we moved 3 units to the right. And the 3 is negative because we have to do the opposite of what we see. Let's move on. In the graph, f of x is the parent function graphed in bold, and the graph of g of x represents a transformation of the graph of f of x. Determine which type of function f of x is and give its equation. Well, we have a half curve. F of x is in bold, and the transformation is below. The transformation is g of x. So going back to f of x, a half curve is called a square root function. And f of x equals the square root of x. Now we need to write a sentence to describe the transformation from f of x to the graph of g of x. If we compare the two graphs, notice how the graph moved 1, 2, 3, 4, 5 units to the right, and 1, 2, 3, 4 units down. The transformation from f of x to g of x is that the graph moved, or translated, 5 units to the right and 4 units down. Now let's look at problem number 10. In the graph given, f of x is the parent function graphed in bold, and the graph of g of x represents a transformation of the graph of f of x. Determine which type of function f of x is and give its equation. So the transformation is the one below. I know that the one in bold is f of x and the one that's highlighted is g of x. This graph looks like an S, and if the graph looks like an S, it's called the cube root function. So f of x equals the cube root of x. Now we need to write a sentence to describe the transformation from f of x to g of x. Let's look for the transformation. Pick a point from f of x. I would go with 0, 0. Think of that as the center of the graph. Now locate the center of g of x. The center of g of x is at 6, -3. Now let's find the transformation. To go from f of x to g of x, we would have to go 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3 units down. Transformation from f of x to g of x is that the graph moved, translated, 6 units to the right and 3 units down. Problem 11. Given that f of x equals the absolute value of x and g of x equals f of x minus 3 minus 5, write the equation of g of x in terms of x. So we're just going to turn the f of x minus 3 into an absolute value. We have g of x is equal to f of x minus 3 minus 5. And once again, because this function is an absolute value, we'll go ahead and turn this piece into an absolute value. We have g of x is equal to the absolute value of x minus 3 minus 5. And that's our answer. Let's look at problem 12. Given f of x equals the square root of x and g of x equals f of x plus 6 plus 4, write the equation for g of x in terms of x. So g of x is equal to f of x plus 6 plus 4. And now we want to replace the f of x plus 6 with the square root. That's going to give us g of x is equal to the square root of x plus 6, and that plus 4 stays outside. This concludes part 2 of our lesson. If you like this video, go ahead and give it a thumbs up and don't forget to subscribe.